Welcome back to part 3 of this ARP avatar repair. I pulled the power supply out and you can see how badly burnt it is, this resistor. And on the back you can see how badly damaged the board is. And also I was drawing attention to this dark patch here, and this is one of these dreaded tantalums that have blown up that I was so worried about in the last 2 videos. So there's proof that these are definitely need to be replaced. So before we tackle the power supply, I think we'll have a look to see if we can get this low E gate working properly. And I found something quite interesting, but I'll just show you. Let me just reconnect it up. So when I first power it up, we can keep an eye on the milliamps there. Of course, now I'm paranoid that any of the tantalums in this circuit can go at any time, so we have to try and work quick. But from a straight power on, we can see that we are triggering that low E. But as soon as I switch to another pickup, I can't go back to that low E. All the others work, so we need to investigate that little circuit there. So here's the circuit for the gate detection. I've been doing a little bit of probing around, and I noticed that on these 2 points we're getting different readings. So if I show you that on the scope, I can show you what we get from the E string and what we get from the A string. And these are quite handily just here and here. So on the E string, Z14 pin 1, which is here, we can see goes down to a negative voltage on the scope. And when I play the string, we do see a reaction on that pin. But if we go to a working one, pin A, you can see it's actually holding at 7.4 volts, and it's a much more drastic response that we're getting. So if we're looking at the schematic, here we're having a low voltage and here it sits at 7.5. So maybe this cap has gone a bit short, or this op amp has gone faulty. So I think I want to replace the op amps and that cap and see what happens. Yep, that's come out nice and cleanly, that has. I think I want to take out these 2 caps. So while I'm here, I'm going to change these 2 tantalums on the main bypass caps here. If they were to blow up, that could be quite catastrophic. So I might as well just put some brand new electrolytics in there.
Inside, we find a tranquil motion. Cunning, you are with me. Our face, our body, life's creation. You are making me. We are making God.
Okay, I've connected everything up, and then let's see if she blows up. Okay, that's good. I don't have the guitar connected yet, but if we check pin 1, pin 1 goes up to 7.4 volts, and the chip we've just replaced, pin 1. Oh, epic! That's up to 7 volts as well. Looks like we might have cured it. Let's plug the guitar back in. Okay, let's see what happens. So we have the E. And now normally if we go back to the E it wouldn't work. Haha. Now that is a result. So this is really looking good for this avatar, especially now we've got the guitar fully working. The pitch to CV is working, all the gates are working. And we have really only 2 faders, the VCO course control and also the high pass fader is a bit dodgy. Apart from that, I think if we can get away with replacing those 2 faders, we can get this working back as intended. Obviously, I will need to recap this whole thing, which is not going to be a very quick job. I'll have to take all the boards out, but there's more tantalums on these boards. And the only other problem left that I can see is VCO1. The sawtooth is fine, but the square wave, it's there, but it's very quiet compared to the sawtooth and the VCO2. You can see they're the same volume. But if I can get the go-ahead to replace all the caps, then that would be a good time whilst the top board is out that I can investigate that square wave on VCO1. So tune in for the next episode where we're going to tackle this power supply, find out if it's 240 volts and maybe consider remaking this PCB from PCBWay.com. So yeah, catch me on the next one.
Show me